Thank you very much. All right, so if you're in the back and you want to scan a big QR code to get the slides, I will also show it at the end. So if you just want the slides for later, I will show that slide again. I'm going to count to 5 and then. All right, all good. So if you're interested by what I'm going to show today, we also have a workshop this afternoon at the Adversary Village from 3 to 5, where we want to basically do what we are talking about now, but hands-on. So my name is Christophe. I work at Datadog, as it was said, and in this talk I'm going to try and give my perspective on detection engineering in the cloud. Specifically, at first I was working in a SOC, in a local SOC, managed detection and response vendor, so I was more like writing rules for customers. Then I moved to a role that was more cloud security engineering, so the same but internally, and now that I work at Datadog it's more like rules that are packaged in the product, so hopefully these 3 different perspectives will be useful. As a first step, I want to spend a few minutes looking at some basics of detection engineering that I think are interesting. So, missing a slide here. Starts well. So what I want to say here is basically that maybe 10 years ago, we were focusing on indicators of compromise, things like IP addresses, hashes, domain names, things like that to detect bad things, right? And in the cloud, we have some cloud-specific IOCs. If you think about attackers trying to spin up malicious Docker images, or attacking from a specific AWS account, running specific malicious AMIs, well, these are also relevant to the cloud, but mostly, I think the industry has been focusing on moving to things that are a bit harder to detect, but also more value, and that attackers have more trouble to change. You've probably seen this pyramid of pain, and basically as you go up, it gets much harder to detect, but also much harder to change for an attacker. So that's a bit where we're going. And there are many ways to try and find what attackers do, but if we have some product managers in the room, this is the user story. What do attackers want to do in the cloud, and what are they trying to do? So that's what I'm going to spend 2 minutes talking about. And I think it's mostly about 3 things. So looking at behavior models, how attackers behave in the cloud, things like MITRE ATT&CK, looking at public cloud incidents that are disclosed, which are sometimes quite hard to find, and also looking at vendor incident response company reports, and try to put these 3 things together to say, I'm going to base my defense based on things I know attackers are doing. So the first one is obviously MITRE ATT&CK. They have a cloud matrix that is cloud specific, but they don't want to be provider specific. So it's useful, but it's quite hard to contribute back to it, and it's not perfect. There is the Kubernetes threat matrix from Microsoft, which is much more Kubernetes focused. The Azure threat matrix as well, which is very low level to Azure. So these things are great, but there's one thing that they're missing. They don't really tell you necessarily everything or how to reproduce the attacks, things like that. We also have things that are based on things that we have seen in different environments. So that's 1, 2. Wiz has one as well. So many things. So that's the first thing, trying to see who has some kind of inventories of the attack techniques in the cloud, I think is the first step. Second one that's very interesting in public cloud incidents. So a few years ago, it was very hard to find. Now there are a few things. So Rami McCarthy has a great repo, AWS Customer Security Incidents, that he maintains, and he does a great job, where he maintains and he updates every time there is a cloud security incident that gets reported on. I also did this work, but for 2021, 2022, trying to find all I could find in terms of public S3 buckets or things like that led to one leak. Chris Farris is also doing a great job with breaches.cloud. That's basically the same, but with much more detail. So if you go there, you will see some root cause analysis and what's up, how they could have been prevented, and things like that. So that's a great source. And starting from 2023, I think at Reinforce 2023, AWS shared for the first time some public things about things they see in customers' environments, namely ransomware in that case. There are some things from vendors as well, so from Microsoft as well. So I think it's more rare, but it's very valuable too, because when they talk about it, it's real. And finally, blog posts and sightings from vendors and incident response companies. So I think we just need to know that they are vendors, so sometimes they are not very neutral, they try to sell you something, but it's still very valuable. So a few IDs, M-Trends from Mendiant, CrowdStrike, the threat hunting report, different things like that. and individual blog posts as well. So we try to do that. We have a few blog posts on things that we have found in actual environments and what attackers do in there. And I also want to call out two companies, Invictus IR and Permiso P0 Labs, which do a great job at doing that as well. So that's the three foundations, trying to find the behavior models of attackers, the public cloud incidents, and the attacker sightings, like the more granular ones. And these three things, obviously, they interact together, right? They are not in isolation. So when you see something in the wild, maybe someone is going to contribute back to one of the models, etc. I think that's a very good basis to try to figure out what attackers do. So now we know. So what do we do now? We know what we need to detect. What do we do? And usually the question is, okay, I'm defending a cloud environment, maybe my company just started to use AWS or Azure. Like, what do I do in terms of threat detection? Because there are so many ways to start and so many ways to get it wrong. So I'm going to split that into three different things, and we're going to dive into each of the ones. The first one is going to be very basic, and it's have a catalog and classify your cloud environments, right? If you don't even know what AWS accounts you have, it's very hard to defend them. It might seem very easy, but sometimes it gets tricky. The second one is to centralize, understand, and enrich the logs. Again, it might seem basic, but generally it's hard to do it right. And finally, be very skeptical against the rules that you are going to implement, and we're going to get back to that. So the first one, having a catalog of cloud accounts. It can be very easy, it can be very hard. Typically, having something very basic, even in a spreadsheet, can be a first step. The first step, what's the account, what's the state, is it dev, prod, do you know what data is in there? And sometimes you can also get some help from your cloud provider TAM. So if you ask your technical account manager at AWS, they are typically able to get any AWS account that was registered with a corporate domain. That can be very helpful. And then if you can automate it, for sure, it's helpful. Centralizing the logs, so it's going to depend a bit on the provider, but for AWS, the typical architecture is having a CloudTrail trail in the management account, and then sending these logs to an S3 bucket somewhere else, so that you don't have this thing in a very privileged account, and sending that to a SIEM. So I'm saying SIEM, but what I mean is anywhere where you can have logs, basically. So whatever, if it's an open source stack, a logs management platform, a SIEM, that works. The point is to have everything in the same place. And what do we mean by everything? Well, there are a lot of logs, right? So it's kind of important to figure out what logs you have, like what you can get and what you should get. So in AWS, it would be called AWS CloudTrail. They have different names in other clouds, but basically it's the control plane audit logs. So whenever you do a cloud API call, it gets registered. That's typically what you want to start with. But you have many other things, data plane logs, VPC flow logs, DNS query logs, etc. That can be very useful, but can be very costly and have a lot of volume. Also the links for all the providers. That's for the cloud, but you have also what runs on top of it. So application level logs, maybe you want to collect that as well, probably. Kubernetes audit logs, and your IDP logs from Okta, Azure AD, etc. that are very useful when you want to combine these different log sources into something that makes sense. Enrichment. You could talk about it for hours, but three things that I found to be very helpful are resolving the cloud account IDs, enriching IP addresses, and email addresses. And really what you want is to turn something like this that gives you minimum information. So that's the numeric AWS account ID, an email, and a source IP into something that you have much more context on. So for instance, you add the account name, you add the account stage, so that at first start, okay, this is a production account. Maybe it belongs to this team, maybe the owner is this person. For the user, you want to have things like HR stuff, like where are they based off, are they in this specific team, who is their manager in case you need to escalate something. That can be very helpful. For IPs, two things I personally like is having some kind of threat intel. There are some commercial products, some open source projects to do that, which tell you, at first sight, well, this is an IP from the US that looks like it's a Tor exit node. Maybe for someone who works in Paris, it's something is going wrong, which you couldn't have seen from something basic like that. And lastly, I tend to be skeptical, and I tend to do it also with detection rules. Basically, if you buy a SIEM or like a security product, they tend to come with thousands of rules, hundreds. It's kind of, if I have more roles, then I'm better than the competitor. And these rules, they create a lot of work, of toil. So my personal strategy is to try and disable everything and then enable rules one by one. And be sure that they don't create too much noise, that they actually create value. So you should be able to create some dashboards, some metrics, some way of figuring out if your alerts are too noisy, if they don't bring value. And finally, in terms of feedback loops, two things. So I'm a strong believer that whoever has to look at the alerts should also be the one writing the alerts. It's like when you page someone, if you are paging yourself, you're going to be much more careful about what you're going to send. So typically this can be with a workflow where when a rule triggers and it shouldn't have, you have something in place to make it better very quickly. And the next thing, it's going to be the last for this section, is continuously challenge the rules, not only in terms of is it valuable, but also is it even working? Because most of the time you'll have a rule that says, I'm detecting that. And maybe it worked, maybe not. So we'll see a bit later how we can do that. That was for basic rules, things that are packaged within security products. At some point you're going to want to add custom rules. So a few tips on that, learned the hard way. So the first thing is to figure out what is this rule trying to do. And from my side, there are three use cases that I think are often there. The first one is detecting malicious activity. That's the most common one that we think about when we say detections. But you have also things that try to detect non-compliance. So if someone disables an S3 bucket public access block, it's probably not an attacker, right? It's probably someone who's trying to do something. And I want to know it because it creates a non-compliance in my environment, but it's not the same. And finally, all the basic rules like a VPC was created in production. But most of the time it's interesting, it's relevant, but you don't want to alert on that. So really you want to split these three categories, maybe more, because what you're going to do for these ones are going to be different. So typically when you have malicious activity, you're going to want to triage and respond to it. When you have something non-compliant, maybe you want to add a compliance exception in your GRC tool, whatever. Maybe you want to just revert it. And for the potentially interesting ones, it's more like, well, if I have an incident, I can get back to that. Or maybe I can do some correlation between different things. But you typically don't want to page people or something like that. Finally, having some context into the alert, it's also linked to having the person who writes the alert being the same as the one who looks at it, or at least being involved. And they need some context. So when you have one alert that pops up, if they have some random name like suspicious IP in AWS logs, whatever, they need to know how it was detected, what was the log source, what was the context, and what they need to do about it to investigate. Otherwise, it's just not actionable and very frustrating. One quick note on severity. I don't have any silver bullet, but just some high-level thoughts. So people tend to see severity as a function of likelihood and impact, which are terrible names. Likelihood for detection, for me, it means how confident are you that this alert is actually detecting what it's supposed to detect. And sometimes you have high confidence rules. Sometimes it's like, well, it's supposed to detect this thing, but we know we have a lot of false positives. So trying to be aware of that is important. And in terms of impact, looking at some contextual information, like is it a test or a production account? That's going to help. Do you know that you have data in this account that is important? Yes, no. So trying to have this kind of dynamic severity can be very helpful if you can do that. Two slides on going to the next stage of writing custom detection rules. So that's more like the more advanced way of doing it, but I think can be helpful when you have a strong basis. And then we're going to move to demo a few things. So having the MITRE attack mappings in your rule metadata is very helpful. So if you are trying to detect new IAM users, for instance, you might add that it's a persistent technique. And then what you can do is first trying to have some nice dashboards around how to display that, but you can also do some correlation rules that say, whatever rule triggers, I want to find the users that have rules that trigger for different stages of the attack lifecycle, which might be very helpful. So that would be one example with SQL. And you could find a user that has some alerts for initial access and for persistence and for privilege escalation, and can give you a good signal that something is wrong, even if you don't do role level correlation. And finally, detection as code. It's a big topic. It could be a talk on its own. What I have personally found to be useful is to use Terraform, but not directly use Terraform to create the rules. Instead, have Terraform read some YAML files, because they are much easier to write and to reason about, and have some schema checks for it. So you can use something like JSON schema, check that your rule has some specific schema, and it means that people who write the rules, they have auto-completion in their IDE. They can know very fast if something is, is like syntax is wrong, and you can put that into CI to make sure that everyone who sends a pull request doesn't mess up the rule. And when we say as code, so obviously that's more of a North Star, but I think when we say as code, it shouldn't be just a word. So when you think about code, it has CI/CD, it has a staging environment, it has unit tests, things like that. So trying to be as close as possible as what you would really have with code can be very helpful. When you want to try out a new detection, you probably want a way to test it. So maybe you deploy it to a different instance of your SIEM. Maybe you tag it in a way that's not going to like page people, or that's going to show up in a different place. But having this workflow is very, very helpful. So now we have some rules. Great. What do? We're at the stage where we have maybe 20, 50 rules, and we're like, great. Is it useful? Like, how do I test if something is working? And typically the flow, which is very simplified, is something like this. So you run one of the attacks. Let's say that you are trying to detect new admin IAM users in your production account. Great. So you can do that. Then you're going to look at what happens. Do you get some interesting logs, alerts, metrics? Are you getting paged? I don't know. And based on that, you're going to develop or improve your existing detection. So that's kind of the SDLC for detections, very simplified. I'm going to focus on these two things. And the first one is going to be Stratus Red Team. Has anyone heard of Stratus Red Team before? Or used it? Okay, a few people, great. And there's also going to be an open source tool that I released 2 hours ago specifically for today. So hopefully you will find it useful. So when we try to reproduce cloud attack techniques, again, we're in the context. I want to test that this rule is working. So I'm going to reproduce the attack and see what happens. It's actually very annoying to do because when you create some cloud resources, it takes some time. It's very hard to clean up, and sometimes it's very tricky. So let's see an example. Let's say you have a rule that detects when someone stops CloudTrail logging in AWS. Very basic one. So what you're going to do is first, to be able to test that, you need a trail, right? You need logging setup. So you're going to create it. You need an S3 bucket. You need the right S3 bucket policy, that I always get wrong. And then at this point, you have a trail. You're like, okay, I can test if my rule is actually working. So you click on stop. Maybe your rule is working or not. So then you want to clean it up, right? Because you have a CloudTrail trail that is not free. You have an S3 bucket, so you don't want that to stay in your account forever. So you click on delete, great, it works. But then you still have the S3 bucket, because deleting the trail doesn't delete the bucket. So you go to the console, you click on delete. Oh, well, since the bucket is not empty, you first need to empty it. So you go back, you refresh, you click on empty, then you have to type permanently delete in the confirmation window. Great, it's empty. Then you go back, you refresh, you click on delete, you enter the bucket name, and you're good. So it was a very, very simple technique, very simple attack, and yet, most of the time you're going to forget to remove something, and it's annoying to set it up. So that's really why we built this tool. It's open source, we released it 2 years ago, and we've been maintaining it since then. The idea is really atomic red team for the cloud. So trying to be able to reproduce cloud attack techniques very simply, everything being packaged in a single binary, and being written in Go. So we'll have a quick demo afterwards, but at a high level, it's really two things. A catalog of cloud attack techniques that we believe are worth detecting based on public things, private things that are being exploited. So that's a wiki, and a CLI tool to reproduce them against a live environment. So at first it supported AWS. Now it's AWS, Azure, Google Cloud, Kubernetes, and even EKS specific attack techniques since yesterday. So if you go to stratus-red-team.cloud, you will see there is this website that has a list of all the attack techniques. And when you click on one, you will get a few things. You will get the mapping to MITRE ATT&CK. You will get the description of the technique, so what is it doing? And this is split into things. Warm-up, so what do you need to be able to reproduce this attack? In our example, we need a CloudTrail trail, an S3 bucket, and then the detonation. Once this is ready, what happens? In that case, we stop the trail from logging. And then there are a few things on detection. So what are the CloudTrail logs that you should get? Are there any guarded finding? Things like that. So the goal is really to do that. And this has two things. In each of the attacks, there are two things that are, again, packaged, so you don't see that, but under the hood, it uses Terraform to spin up the prerequisite infrastructure. And for the actual attack, it uses a piece of Go code because it's imperative. And so that's why it's actually quite easy for us to clean up, because you just do Terraform destroy under the hood. But again, that's totally hidden, so you, as someone who uses it, it's just a binary, as I'm going to show. So, quick demo. It's going to be a bit challenging to speak, trail, whatever, or your SIEM, search for all the events that you get and try to figure out, well, I did something, but what did it actually trigger? I have a bunch of logs, but was this done by my command, or was it something else that someone else did? Yeah, that's the contest. So that's why I worked on a tool that's called Grimoire. It's a French word, I think it's an English word as well. And the idea is to be able to generate data sets of cloud audit logs for common attacks in a simple way. So the idea is that it makes creating new rules easier and figuring out what logs are caused by specific attacks. The idea is quite simple. So it can use different ways of detonating attacks. You can use the AWS CLI manually, or you can use Stratus Red Team to run some attacks. It's going to inject a unique ID in the HTTP user agent of the request, and then it's going to basically poll CloudTrail, looking for this specific UID in the user agent. And the idea is that you can do that without leaving your terminal. So let's do a quick demo, which is going to be live, so it's going to take a bit of time. So I'm going to run Grimoire Stratus Red Team, giving it a specific attack technique, AWS persistence, create an IAM user, and stream the logs that it finds somewhere else. So what it's going to do right now is use Stratus Red Team to run the attack, and then it's going to look for CloudTrail events. So that's going to take a few seconds. I think for these events, it takes like 2 or 3 minutes. So we can just wait and see something else in the meantime, which is the other mode that Grimoire has, which is Grimoire Shell. So in many cases, you don't necessarily want to use a tool like Stratus Red Team, you want to run commands by yourself. So what this is going to do is it's going to create a new shell, and it's going to use some specific AWS CLI environment variables to inject the UID in the requests. So now if I do AWS STS get color identity, for instance, and then I exit my instrumented shell, it's going to go back to Grimoire, start looking for CloudTrail events, and at some point it will show what logs you get. Now, if we get back to our first tab, you can see that it has now found these 2 events. It's going to find another one if I wait for a few more seconds, but I can just Control C is going to exit cleanly, and then in these TMP logs, I have my raw CloudTrail logs that I can watch and see. Oh, okay, so I got these logs, so I can use these rules and maybe pipe back into my CM to see what happens, or different things like that. It will be the same for the interactive shell, just going to take 10 or, up to 10 minutes, so I'm not going to wait for that. It's the same principle. So that's the first meme, and it's been 30 minutes almost. So, they work together in the way that you have seen, so you can use Grimoire to detonate Stratus Red Team attacks, but we also wanted to use it the other way. So now in the Stratus Red Team docs, if you look at one of the attack technique docs, you also have the actual detonation logs, the actual CloudTrail logs that running the attack gives you. So you have the event names, and you also have the event, the actual raw events. So if I just go to the to the website, for instance, for this one, you see here we have this section that is powered by Grimoire, which tells you, well, if you were to run this thing in an actual live account, you would get this log, and this is the actual event that you get. And we anonymize this using a tool from Permiso P0 Labs called Log Leaker. So that's pretty much it for Grimoire. So again, it's open source. We released it today. So if you want to contribute or if you want to test it, I'm really eager to get some feedback, and that would be amazing. A few closing notes. So the TLDR is like, be aware of what attackers do, and that can be quite hard, but having a basic awareness of what to read, what to look at can be very helpful. Be aware of what logs you have, and what they are used for. And finally, like, don't trust rules, test them, and challenge them both in terms of value and in terms of are they actually working. That would be the conclusion. Again, if you're interested to do something like that in practice, I'm running a free workshop at the Adversary Village later today. So we're going to spin up a vulnerable AWS application, hack it end-to-end, then we're going to write the detection rules, and then use Stratus Red Team to confirm DDoS detections, detect what we want to detect. So that's it. That's the QR code to the slide. There is also a feedback form, so if you have things to say or that you wish, please add it. Thank you.